This is lesson 8-2D from the Algebra Readiness textbook. For today's lesson, work the study guide problem first, then continue the video when you're ready to compare your answer to mine. When solving problems such as these, we learned originally to use domain or x values of -2, -1, 0, 1, and 2 until we had fractions. And once we had a fraction coefficient, we said, you know what? Those aren't necessarily the easiest numbers to multiply by. Instead, we choose numbers that are multiples of the denominator. In this case, we'll use -3, 0, 3, 6. And then we'll substitute those numbers in for x because that will make the fraction go away. So we have -1/3 times, and then when you insert it as a fraction, -3/1 plus 1. These cross out. 1 plus 1 is 2. Then again, we repeatedly solve the equation. 0 plus 1 is 1. -1/3 times 3/1 is -1 plus 1 is 0. -1/3 times 6/1 is -2 plus 1 is -1. Every entry in my table is an ordered pair that can be plotted on the graph. The first ordered pair is -3, 2. So starting from the origin, as always, I go back 3 and up 2. And I place a dot. The next thing is 0, 1. I don't go left or right any, and I just go up 1. Then over 3, and then I don't go up or down any. And lastly, 6, -1. I go over 6 and down 1. Then I ask myself, is this a linear function? Well, it sure is linear. It is a straight line, and it is a function because the x values do not repeat, and this would easily pass the vertical line test. When you take a vertical line and drag it across my graph, the graph would never cross my vertical line in more than one spot at any given moment. So today's learning target is to solve for y first. This time, what if I gave you an equation that looked like this? Do you see that? What I have is my y isn't by itself. I've got a -2x after it. So your job is to simply get the y value by itself. So how do we get y by itself? I see it's subtracting 2x, so I'm going to add 2x to both sides. Y equals 2x plus 4. Now, if you wanted me to graph that equation, I could make a table and solve for my x values. But until then, I couldn't do that. Take a look at the next one. Y plus 3. Notice that the y value is not by itself. I need to subtract 3 from both sides of the equal sign. Do not mistakenly call 5x minus 3 2x. It is not 2x because those are not like terms. 5x minus 3 just stays like this. Now I have an equation that I could make a table of. How about this last one? This last one looks a little tricky, doesn't it? This one, I see that y is right here. I need to get rid of this plus 2x to begin. So I'm going to write 2y equals -2x plus 2. Y still is not by itself, so I divide both sides by 2. When I divide both sides by 2, I want you to know that you're responsible for dividing each term by 2. That means I need to take -2x divided by 2 and 2 over 2. See how I divided each thing by 2? So how are we going to do that? Let's simplify. Negative 2 over 2 is negative 1. Y equals negative 1x. And then over here, 2 divided by 2 is 1. And so I have that equation. Okay, let's try these now. I want to get y by itself. Let's add 3 to both sides. 2y equals 12 plus 3 is 15. Now I divide both sides by 2, and y equals 7.5. Okay, let's try the last one on this page. Start off, we want to get this y by itself. So I add x. I always undo adding or subtracting first. 2y equals, I like to write my x first, x plus 12. Now y is still not by itself, so I need to divide both sides by 2. So this is really 1x, isn't it? So I'm going to divide this by 2 and this by 2. Everything on that side is divided by 2. So what's left is y equals 1/2 x plus 12 divided by 2 is 6. All right, we're going to use some more practice solving for y before we start worrying about the graphing. So what I would like you to do is pause the video at this time and solve each of these 5 equations for y. Then continue the video when you're ready to compare your answers to mine. I'm going to highlight the y values in each of these equations so that your focus is on getting the highlighted y all by itself. The first thing that I need to do in the first problem is to add 2x. Now I have y equals 2x plus 4. Now if you wrote 4 plus 2x, you know that that's the same thing because the commutative property says so, that you can write addition problems in any order. But let's try to write the x value first. Here I've got y plus 3. How do I get y by itself? Subtract 3. Y equals 5x minus 3. Oh, did I just do these? We sure did. Okay, let's do these. As a reminder, minus 2x on both sides. 2y equals negative 2x plus 2. Now I divide by 2. You have to divide each thing by 2. And you're ending up with y equals negative 1x plus 1. Okay, let's try these. Y is multiplying by negative 4, so I need to divide by negative 4. So y equals negative 1/4 x plus 48 divided by 4 is 12. The last one, add 3x to both sides. 2y equals 3x plus 6. Then divide both sides by 2. Y equals, now leave this one improper, always, plus 3. There we go. All right, so now that we've had some practice solving for y, we're ready to do some graphing of the equation. So we solve for y, make a table, then graph. All right, for this one, I'd really like you to try solving for y on your own. Pause the video, solve for y, make a table, graph it, then come back to compare your answer to mine. The first thing I see is I need to get the y by itself, so I get negative 3x minus 5. When I make a table, this is a whole number. Negative 3 is a whole number, so we'll go back to using negative 2. In fact, let's just do negative 2 0, and 2 for x, so that this goes just a little bit faster. Y equals negative 3x minus 5, negative 3 times negative 2 minus 5. So negative 3 times negative 2 is 6, 6 minus 5 is 1. The next one, let's solve it again. That's 0, 0 minus 5 is negative 5. Solving it one last time, negative 3 times 2 is negative 6. Negative 6 minus 5 is negative 11. So let's try. Back 2, up 1, 0, negative 5, and 2, negative 11. Oop, I went just a little off the page, didn't I? And then you're left with a graph that looks like this. Okay, so the graphing, making a table and graphing the table is all the same. The only added step is right here, where you solve for y first. Okay, again, try this one. Pause the video, solve for y, and then continue when you're ready to compare your answers. I see that I should subtract 2x from both sides. Y equals negative 2x plus 3. Okay, this is a whole number, so go ahead and use negative 2, negative 1, 0, 1, and 2, or just use negative 2, 0, 2. Okay, then we put in negative 2 times negative 2 plus 3. 4 plus 3 is 7. Then negative 2 times negative 1 plus 3 gives me 5. Then negative 2 times 0 plus 3 gives me 3. And then negative 2, oopsie, I don't know what I have going on there. So 7, 5, 3, the next one is going to be 1. And so now I'm ready to graph. Negative 2, 7. You can graph that one. We're going to make this go a little faster. We want to focus on practicing the solving for y and making a table. All right, letter B, solve it. Also solve this one. Try B and C with the video on pause, and then continue when you're ready to compare those answers. Okay. So this one, you should add x to both sides. Y equals x plus 5, and then make a table and graph it. The table of this one looks like this. Okay, the next one. This one is a little trickier. We got to add 3x to both sides, and this goes away. You're left with 2y equals 3x plus 6. Then you need to divide both sides by 2. So this is the part that people get caught up on. Y equals 3 over 2x plus 6 divided by 2 is 3. Notice how I divided each term by 2. Okay, and then of course you would graph. This time, just as a review, when you make a table for this one, because my denominator is 2, you want to use multiples of 2. So negative 2, 0, 2, 4, for example, when you're making your table. That way your fraction goes away. Okay, solving this one. Y minus 1/2 x equals 0. I believe this is the last one for today. And so to solve this one, we want to add 1/2 x to both sides. Y equals 1/2 x. So in my table of x values, this is a fraction, so I go up in multiples of my denominator. So going up by 2's, negative 2, 0, 2, 4. And then y equals 1/2 x. So I go 1/2 times negative 2 over 1. And I get negative 1. Then I do it again. 1/2 times 0. And I get 0. Then I do 1/2 times 2. And I get 1. And then I would get 1/2 times 4, and I get 2. Now I'm ready to graph that table. So the equation y equals 12x plus 6 can be used to estimate y, the height of a tree in centimeters, x months after it's planted. When a tree is 150 centimeters tall, how long ago was it planted? So when you're figuring this one out, 150 centimeters tall, that would say you have to look at what each of the variables mean. Should you substitute 150 in for y, or should you substitute that in for x? I see that y is the height of the tree in centimeters. So I would say 150 equals 12x plus 60. I'm looking for the solution. When y is 150, what is x? So then you plug it in and you solve the equation. And I end up with and you divide both sides by 12, and then you do 90 divided by 12. 12 goes into 90. Let's see. So my answer is A, 7.5. All right, we're ready to give the homework a try. It is the 8-2D Graphing Linear Equations worksheet.